So in this last example, we're going to talk about how you would use an inverse trig function to be able to model something in the real world. In this particular example, we're talking about optimizing an angle for a shot putter. So here we have a shot putter who, when he releases that shot put, his arm is extended a height above the horizon, and he should be releasing the shot put. He has some momentum or some velocity that he's throwing it at, and the question says, or the formula that we're looking at, what is this angle going to be to maximize his height so that he can get the greatest distance, because that's kind of the name of the game for these shot putters. And it's given by this equation right here. You can see it's the inverse sine or arc sine of this right here. So if in this particular example we're looking at the shot putter having a height of 7.5 feet, so up here 7.5 feet above the horizon, and he consistently throws this at 50 feet per second, I'm just going to replace v and h in this equation to find out what theta is, so we can tell this guy what his optimal angle is to get the greatest distance. So we're just going to replace it in this equation right here. This is really just a calculator problem, but let's see if we can come up with the same answers. So I'm going to take the inverse sine or arc sine, and in the numerator I would have 50 squared divided by 2 times 50 squared, because that's the velocity, plus 64 times 7.5. All of this is under the radical, and then we take the inverse sine of it. So let's see if we can get it put into the calculator correctly. So I have underneath the radical in the numerator, I have 50 squared. So I'm going to put 50 squared and close that and divide it by what I have going on here in the denominator. So I have 2 times 50, 2 times 50 squared plus 64 times 7.5. Now the calculator knows these order of operations. It knows to do the exponents and then the multiplication before we do the addition, so I don't have to worry about too much down there. I'm just going to close the denominator's parentheses and ask the calculator to find the square root of that, and it's 0.675. Then we're going to take the inverse sine, so the inverse sine of what I just calculated, and we do need to be in degree mode, so I think I'm still in degree mode. Let me just check really fast. Let's see. I'm still in degree mode, so that's good. And let's calculate that out. So the inverse sine of that value there says that this guy needs to be releasing his shot put at an angle of 42 degrees, 42.5 degrees with the horizon to get his maximum distance out of this. So do I really think that you're going to come up with an equation like this? No, but I do want to point out that there are a lot of uses for finding the angle of something happening. In this particular case, you can think of shot putting, you can think of baseball, hitting a baseball, you can think of golfing. Somebody has to come up with, say, a radar that tells you this information right here, and that radar or that information from that motion detector is being fed into a computer and doing this calculation. So somebody has to do that. So maybe a programmer or somebody who understands inverses. Another application that I'm kind of always been interested in is angle of elevation, or this inverse, taking the inverse of a function to get the angle, is applied in forensic science for blood splatter. If I wanted to know, say, a victim, where was the victim at, how tall was the victim at when his blood came down and, I don't know, splattered on the ground. So this is a way for you to figure out what theta is, and they use that in forensic science a lot. So here's an example in sports. This is an example in forensic science, and there are multiple examples of inverse sine or inverse trig functions being used in everyday life.